Go ahead and open up to page 307 if you're not already there. You have already learned both in Algebra 1 and we've reviewed in Algebra 2 how to solve quadratics. Now, just to be sure you're all aware of what a quadratic is, if you look at the top of page 307, it gives you what a quadratic looks like. A coefficient of x squared, whether it be 1 or something else, combined with a coefficient of a variable to the first power, combined with a constant equals 0. This is a typical layout of a quadratic. Okay. Now, let me show you what you've already learned. If I said to you, solve x squared plus 2x equals -1, this is a really, really easy one. You learn to zero out the equation by adding your 2x back over. And you learned to factor this to figure out what options for x would create a true scenario. This happens to be a perfect square, but for sake of argument, I'm going to factor it for you in a clear way like that. Solve both pieces for 0. Of course, they're both going to equal the exact same thing. X would equal -1 in this scenario. Okay? You wouldn't have to write it twice. But that is what you have done up to this point for solving quadratics. Now, all quadratics are not quite that simple to solve. And whether the factoring gets more difficult or other things, there are other things that would make it more difficult. In any case, this chapter, chapter 7, focuses on solving quadratic equations using various methods. And today's method is known as completing the square. Now, you're going to see completing the square both today and tomorrow, so don't worry if you feel uncomfortable today. But let me go ahead and introduce you to what we're talking about here, starting with example 1. Again, we're on 307 in the Algebra 2 book. It gives you a couple of things to solve. X minus 3 squared equals 7. You're saying to me, wait a minute, that doesn't quite look like that. Well, if I were to FOIL this out, it would look exactly like this. Okay, I would bring my 7 over in whatever case. But this x minus 3 squared makes solving this a little bit easier. Instead of me attempting to multiply this out, subtract my 7 over, zeroing out, and then try to factor it, I can see that my answer can be obtained by rooting, so to speak, both sides. The square root of x minus 3 squared is x minus 3. The square root of 7 can be a positive or negative, whatever the square root of 7 is. If you plugged it in your calculator, you'd get some crazy number, right? All right. Continuing, I can add 3 to both sides, and now I have x equals the positive or negative square root of 7 plus 3, which you're going to see from your book, the way they usually write it is 3 plus, and that's the positive radical 7, or 3 minus radical 7. Okay? This is going to be the way you'll see the answers if you verify your odds. In any case, this is the rooting out the process here if you have an opportunity to do so. So B, I'm going to give you another one that looks very similar. 2x minus 3 squared equals 7. Okay, instead of multiplying this out, subtracting over my 7, and trying to factor it, and if it's not factorable, you're stuck, we're going to find the square root of each side. I always call it rooting out. So if you hear me say rooting out, I'm finding the square root of each side. The square root of 2x minus 3 squared is 2x minus 3. The square root of 7 is going to be, again, either a positive or a negative radical 7. Okay? I'm going to add 3 to both sides and then divide by 2. And it's going to look like this. I'm going to write it the way they do it. Divide by 2, divide by 2, and x is equal to 3 plus radical 7 over 2. It can also be equal to 3 minus the square root of 7 over 2. Okay, that would be your solution set. It's 3 plus because a root can either be positive or a negative. Okay, because when you square it, you get that number anyway. Okay? This scenario here is extremely helpful when you have a perfect square being created, right? Up here, I had x plus 1 squared. Okay? But what if, back up here, my equation was x plus 2x plus 1 equals 4, positive 4. I would subtract that 4 over, and I would have x plus 2x minus 3. Let's make it a 5. I'm trying to come up with a way where it's not factorable, and I might not be able to do it right off the top of my head. Negative 4 and 1, negative 2. Yeah. Okay, so if I tried to factor this, I would test 4 and 1 somehow, and I wouldn't be able to achieve a 2. I would test 2 and 2, and I would not be able to achieve that center. So you would, up to this point, have said, how do I solve this using this method? Okay? On the next page, I am going to show you exactly how to do that. And this is where we encounter our method known as completing the square. Example 2. Top of the page. Now, right below example 2, as you can see, there is a step-by-step layout of the process that I am about to share with you. Okay? The process I'm about to share with you is a way of creating a perfect square so that it is solvable like the method on example 1. So, here we go. Example 2. We're going to complete the square. What on earth is that? Well, I'll show you. Minus 3 equals 0. Mrs. Myers, this isn't factorable. I can't solve it in any way that I know of. Okay, very good. Okay, step 1. You are going to remove that item that we've traditionally moved over to 0 out. X squared minus 6x is positive 3. Okay, so we've been zeroing out to this point, but now we're undoing that. Okay, step 2. Look at the coefficient of the square. Since it is a 1, we're going to go ahead and continue. There is a little bit more work to be done if it were not a 1, and you'll see that in example 3, but for right now, we can continue on to step 2. Okay, here it is. Take half of the coefficient of x, which is a 3. Okay, half the coefficient of x, which is a 3. Square it, which gives you a 9, and add it to both sides. I now have x squared minus 6x plus 9 equals 12. Okay? This is now a perfect square. It is a perfect square. And I know you're thinking, well, it's a negative 3 technically. Yes, but I don't care about that because I know if it's negative or positive, it's going to become positive anyway when I square it. So if you look in the book and you say, wait a second, they took negative 6 divided by 2 and squared it. Well, yeah, that's what I did. Negative 6 divided by 2, which is a 3, squared it, and I get a 9. I just didn't make that detail there. Now, I can factor. This is a perfect square, which is x minus 3 squared equals 12. Go back to method 1 from the first example. Root out both sides. X minus 3 is equal to the square root of 12. The square root of 12 becomes 2 radical 3. Okay? 2 radical 3. I pulled out the square root of 4, which is a 2. So positive or negative. Remember, we're rooting here. We're not giving the simplest answer. We're actually finding the actual root. So if I squared a positive 2, that would bring a 4 in here, making it a 12. If I squared a negative 2, that would make a 4 multiplied by 3 to give me a 12, which is why either of those is correct. Add 3 to both sides, and you're going to find the answer to be 3 plus or minus 2 radical 3. And as you check your work in the book, you're going to see the answers listed 2 radical 3 separately. Negative, or 3 minus 2 radical 3. Okay? Those are the solutions the way you'll see them in the back of the book. 3 plus 2 radical 3, 3 minus 2 radical 3. Okay? And there is the step-by-step process down there, 1 through 6. Okay? About the first, say, 1 through, or 5 through, I don't know. Yeah, you probably have about 3, 6, 9 of those that will have no coefficient for x. Example 3 is the same steps, the same process, but what if the coefficient is something other than a 1? I'm going to show you that right now. 2y squared plus 2y plus 5 equals 0. If you tried to factor it and solve it the old-fashioned way, you would find it is not possible. Okay? So step 1 up here was to remove that constant, subtract it. That removes it. Now I have 2y squared plus 2y is equal to negative 5. Step 3, verify that the coefficient of your square is a 1. Oh, it's not. Since it is not a 1, anything other than a 1 requires that you divide the entire scenario by the coefficient of the square. The coefficient of the square is a 2. So now I have y squared plus y equals negative 5 halves. Okay? Negative 5 halves. Continuing, we can go back to step 3 from example 2, which was take half the coefficient of the middle value, the linear. So I've been calling it x, but take half the coefficient of this. 1, half of 1 is a half. Square it. That gives me 1/4. And add it to both sides. This is going to feel a little clunky, but it's doable. Okay. That makes something nice and pretty on this side. Y squared plus y plus 1/4 equals the sum of negative 5 halves and positive 1/4, which most of you would know how to do. So 10/4 added to a 1/4. 10/4 negative, 1/4 positive is a negative 9/4. Okay? Negative 9/4. You thought we were done with imaginary numbers? We're not. We're still going to use them a little bit. This is now a perfect square. Y plus 1/2 squared is equal to negative 9/4. Root out both sides. The square root of each gives me y plus a half is equivalent to I 3/2, right? Plus or minus 3/2 I. Okay? The square root of 9/4 is 3/2. The square root of negative 1 is I. Okay? So, plus or minus 3/2 I. Okay? Subtract a half to both sides. And now I have y equals negative 1/2 plus 3/2 I, negative 1/2 minus 3/2 I. And those are your answers. Whoops, let me push that up a little bit more. Those are your answers, okay? I'm going to show you just one more sample really quick, just to give you at least a few more items to work with, okay? Let's go with, here, let's see what I have. Let me get a couple more from my book. Hang on, I'm on the wrong page. Forgive me. Okay. Let's see. Trying to find one that isn't really, really ugly so that you can feel confident that you know how to do the squaring and all that stuff. Okay, let's do this one. Here's one. Again, this is similar to example 2, which is where the coefficient of the square is a 1. Okay, this will be similar to example 2. So, here we go. X squared plus 6x plus 13 is 0. The old-fashioned way would have you attempting to factor. 13 is a prime, so the only factors are 1 and 13. No good. We're going to use the completing of the square method. I have now pulled out my negative 13. Verify that the coefficient of x squared is a 1. Since it is, we can simply take half the coefficient of x, the linear term, square it, and add it to both sides. I now have x squared, what was that, plus 6x plus 9 equals, looks like a negative 4, okay? Looks like a negative 4. Square, perfect square factor. Root out both sides. X plus 3 equals square root of negative 4 is 2i. Okay? Square root of negative 4 is 2i. Subtract 3, x equals, here are your answers, negative 3 plus 2i, negative 3 minus 2i. You have to have both, otherwise you're half wrong. Let's do another example where the coefficient is not a 1, and that'll get us through today's lesson. Example 3. Come on, book, where's another example? Okay, here we go. This one's a little bit sketchy, but you'll be okay. 7x squared minus 8x plus 3 equals 0. This, 7 times 3 is 21. There are no factors of this that'll get us this. So we're going to go with the completing of the square method by subtracting out. Verify that this is a 1. If it is not, divide everything by the coefficient of the square. I now have x squared minus, Lord, 8/7 equals negative 3/7. Holy cow. Half of this. So half of 8/7. Okay, you should have something that looks like that. Take half the coefficient of that. Good Lord. Let's reduce that. I think that would be quicker. So reduce it to 4/7. A whole lot quicker, guys. So remember, this is a negative. Half, I reduced it because squaring it would be real ugly. You can reduce if you have to. So this is 16/49. Much more easy to work with. 16/49. So if you get to a place where you found half of a fraction and it looks like a real pain in the rump to square, but it is reducible, reduce it and then square it. You're still reducing or squaring the same exact number, it's just in a better form. 16/49 is going to get added to both sides. That's going to be fun to work with. So this is a -21/49. Okay, I just changed that. So x squared minus 8/7 x plus 16/49 equals the sum of 3/7 and 16/49, which after it's all said and done, the difference here is -5/49. Boy, this is going to be an ugly one to work with. Okay, this still is a perfect square, x minus 4/7 squared. Remember, if something's a perfect squared, a squared, twice the product of a and b, so 4/7 and 4/7 gives us that. B squared gave us that, so we are correct. Equals -5/49. Just because the numbers are clunky doesn't mean it's not doable, okay? We added our 16/49. We factored it. Now we have to root it out. Ooh, this is going to be fun. So it's x minus 4/7, that's easy, is equal to -5/49. So I'm just going to kind of show it to you here. We're going to make this I5, and that's going to be plus or minus, over 7. Okay, you guys see how I took this, separated it. This doesn't have a square root, but the -1 does, so the I came out, plus or minus. The 49 is a perfect square, pulled out my 7. Lastly, add 4/7. Add 4/7. And your solution includes 4/7 plus I5/7, that's the positive, and 4/7 minus, for the negative, I5/7. Both of those are needed. This is the toughest kind of situation you're going to have to deal with because of the math, okay? Because of the dealing with the fractions. If you are diligent and verify your work as you go, make sure you have the right fractions, reduce where you can before squaring, you should do fine. Today is odds only, but I expect to see all kinds of work, obviously. Have a great day.